Uh, First of all, welcome everyone to Pulsar Summit. Again, I'm also very excited for this year. It's the second time we've been here like last year. And I want to start as well from where we left off last year. And our quest for illustrate a bit the journey for the omni-comprehensive data streaming platform. We kind of started one thing we always talked about was about operational domain versus the analytical domain, and how in operational domain you have things like message passing between components, application and services, and analytical domain is more aggregating sources of events that has happened already and then analyzing them. And this is like a very broad classification that we've been using for long, but it is, I think, is useful to define the scope and the intention of the use case of the applications. And Pulsar has been one of the only systems that can play well in these two domains, right? The one thing that we've seen during the past few years, though, has been like that there is kind of a bit, the lines are getting blurred and blurred, and the use cases are kind of like intersecting a bit more. And there are a few reasons for that. One is that more and more use cases are very driven by data, so getting data, analyzing data, and then using that data to feed back into the core logic of the applications. And so this is kind of like one main motivation for these two domains to start crossing. And another way to tie back to last year Keynote and narrative was that we kind of laid down the path that there are a few fundamentals of the modern data-driven application, event-driven application. And at the core, you have topics, which are kind of like the traditional PubSub model. And you can see topic data in multiple ways, as a stream, or as a queue, or even as a table. And you can play around with the same data in this different form. You might need to have different access patterns, like either shared access pattern or exclusive access pattern, and with different processing semantics, at most once, at least once, and exactly once. And the final one was a different level of abstraction, meaning you might want to have different access level for different use cases. You might want to have high level with ease of use and very simple semantics, or more low level, but with more control and more freedom to do things in a more performant way when you need that. And if you look at it from a different perspective, so people look at these platforms in different ways. If you look at it from a developer point of view, developers are caring for some properties that are different from other perspectives. So if you ask the developer, typically they want to use the best tool for a job. And for the best tool for a job, in this case, we typically think about what is the best level of abstraction. You need to provide a developer with the right set of primitives, the right set of semantics. And that has to be easy to understand, and it has to be easy to reason about. What are my guarantees if I do this? What happens if I use this API? Another thing that matters a lot to developers is feature richness. If you're trying to build a very complex distributed application, you have already a lot to build on your plate. And you want the platform to provide you to solve all the hard problems around distributed messaging and building things that are durable and scalable, and that can take away a huge part of the application developer job. Just saying that you have a low-level distributed platform, if you have to build 80% on top of that, that's going to become very difficult for developers. And finally, one thing that is typically on the mind is how can I map my use case into a messaging use case? And if you can make it easier for the developers, so that if I reason in a certain way of I see this as a queuing problem or as a streaming problem, and I can map directly from what I'm thinking as a business problem into a messaging problem, that becomes very easy for a developer to do that architecture, that implementation. Instead, if it has to transform and if there is an impedance mismatch between the two, then it complicates a lot of things. On the other hand, if you look at from an organization perspective, there are a few different things that are of a consideration when you're choosing a platform, when you're like investing in a platform, right? And sure, a company will be interested in having that developer productivity, making that developers happy, but they will also have different considerations. So for example, you might want to, if you are an organization, you will have multiple use cases and with different workloads and very different kind of scenarios. And you don't want to have like 10 different platforms, one per each. So you want to standardize on a single platform that can do all of the use cases, or at least most of them, in the best way. And another one that is very important is to encourage a culture of sharing data. If you have a large engineering organization, you have multiple teams doing different components, different services, different sources of data. And having the ability to share data between different teams in an easy way, it is very important. Because otherwise you have data silos and you cannot really unblock the full power of the data you have. If you make it difficult from team A is generating some data and team B has no way easy way to get access to that data in a safe manner. Organizations do also care about cost-effective solution. So when you run at scale, you have different categories of cost, and one is the cost of hardware. So like if you have many use cases, you will need a lot of machines and it will cost a lot of money. So if you can reduce that and consolidate into a single cluster, for example, it becomes very advantageous on the hardware perspective. And the other one is operating costs. So sure, hardware costs money, but it also costs engineering time to maintain. So if you have a cluster, it takes a lot more engineering effort to keep this cluster up and running, to monitor them, to upgrade them, and so on. And fourth and last, the strong guarantees on availability and durability. We've seen that in a lot of these use cases, especially on the operational domain. These are very critical use cases that are in for like mission-critical applications for these companies. And therefore, the guarantees on data durability and availability of the systems becomes more and more important. And sure, some people will say that you don't need to have synced data. Typically, it's the people that don't have a good story on syncing the data on the disk that will tell you that. But that extra level of protection is very important when you can relate to the chances of losing even a small portion of these messages. And if one message is like one user account, someone buying something on your application, then it becomes more and more important. So I want to next go on and show like what we have been doing to make this, to moving into this right direction here, starting from developers. So if you look, and the first part that we have been working in the last 1 year has been around improving non-Java clients. We had already several client SDKs in C++, Go, and Python, Node.js, C#, and others, but we kind of like, we were not at feature parity with Java, so Java typically had the latest features, but in these languages we didn't have the latest features. We have worked a lot on improving the stability of these client SDKs, and one of the main friction points was that we didn't have precompiled binaries for, say, Python or Node.js. So now it becomes much easier. You can just do, if you're in Node.js, you can do that, just do npm install. We just download the precompiled binary for your platform. Same with Python, we have all the matrix of possible binaries. So that becomes much more accessible on that front. And finally, one other thing is that the source code for this client SDKs has been split from the main repo. So now we can do much more frequent releases. It is more agile process to have new releases for client SDKs. Another one feature that I really like a lot is the scalable delay delivery. So you can think of delay delivery as a feature that it was introduced in Pulsar 2.4, but essentially you can publish a message and have a delay assigned to this message, or timestamp with an absolute timestamp. It can be used for multiple different reasons. So you can do like a retry operation. Something failed, you can want to retry this operation later, or you can use it as a scheduler of tasks, or more generally like as a distributed cron-like service. Now, the existing implementation that we had since 2.4, it was okay, but it has few limitations. For example, like the index between the timestamp and the message ID was kept in memory. Now, that means that if you have millions and millions of these delayed messages, that ends up using lots of memory. And there's an upper bound there. And the other problem was that this index is kept in memory, and it has to be rebuilt if you move the topic to a different broker. So there's a lot of background reads that will have to happen to rebuild that index. So with PIP 195, there's a new mechanism that is using a bucket system. And now we don't, basically the index does not have to be in memory all at the same time. And we don't need to rebuild that index when we move the topic. So essentially, you can have as many messages in this delayed delivery queue model, and also offer a lot better isolation between different tenants. So since we don't use that much memory, we don't affect other tenants on the same brokers. Another aspect of making developer life easier is what can we do to unlock better architecture for application developers. So a common problem has been, so you have your application and you have to decide how to map your business domain into topics, essentially. And typically you have few different options. Like either I can use one single partition topic for all my users, all my customers, all my resources in a way, right? Or I can use one topic per customer. And people say, okay, which way is better? And there are different reasons to go one route or the other, right? So, but if you look at the one single partition topic, basically everything gets multiplexed into one single topic. Now you have hash-based partitioning, so the same key will go to the same partition, it's fine. But in this model, basically you don't have visibility on how many events for single users are on your topic, because everything gets mixed up. Also, you don't have a lot of isolation between noisy neighbors. So if you have user 1 that has X messages, and you have user 2 that has 10X or 100X messages, there's no fairness. So user 1 can be delayed because of the amount of data on user 2. And you cannot apply any fair dispatch logic, say 1 and 1, or you cannot do any rate limiting for customer because you do have that messages piled up there. If you go on the other route, though, you could have one topic per each user. Now, it's kind of like you have now more visibility on what's happening per each of your users, because you can see, okay, how many messages are sending each of them, how many messages I'm backed up on each of them. And you can also say, I want to just replay and scan all the events for a single user, which you couldn't do in the other case. You have isolation, and you can apply either like fair round-robin dispatch, or you can say prioritize one customer versus the other based on different business consideration. So it's a very different model, and but in order to deliver on the promise of this model, you basically the system needs to be able to work for any number of topics, or at least for a very high number of topics, which is kind of a challenge for infrastructure software, right? So today, Pulsar runs at most 1 million topics, 1 to 2 million topics. But what we do want to achieve here is to want to go 10x or 100x supporting in number of topics. That basically will free application developer to not fear that model anymore, and you can have much more simplified architecture because of that. So last year we have been announced that we were working on a Zookeeper replacement, and we have announced the release open source earlier this year in April. And so we announced Oxia. So Oxia, essentially, it is a system that we have created in open source to solve metadata coordination problems at a large scale without making any compromising on how much of this data or how much throughput we need to achieve. And it is based on a new architecture that takes advantage of modern cloud environments. So basically, we base on Kubernetes instead of assuming bare metal. And we are announcing today that we have a private preview of Oxia in SN Cloud. And shifting a bit the gear and looking more on the organization and operational side, I want to go back a bit on the multi-tenancy. So multi-tenancy is really the key to achieve low cost of operation. Like if you have to maintain many clusters, it is very difficult to have low cost of operations because there is a lot of engineering time, a lot of hardware, and so on. But having a single cluster, basically we don't have to provision all the slack capacity for every single use case. We can just basically have it as a shared slack capacity into this single cluster. Also, we don't have to provision for the worst case scenario because we don't have to retain data for assuming that everyone will have an outage today. We can assume that only a fraction of our consumers, our use cases will have, application might have an outage at a given point in time. Now, if they do have all at the same time, we can still increase the cluster. Dynamically, it is very easy, but the point there is that we don't have to pay for this extra capacity always, and we can just have some room to accommodate for failures and for people backing up the data. But the other part is easy access to data. So for easy access to data, there are two parts. One is technical. So if you do have a shared cluster, the data is there, and everyone has connectivity, you just need to open the gate. So you can control with using ACLs and give permission for people to read the data. And it is one click away. The other part is more like a process and organizational problem. So if you think that, OK, team A is generating data, they have their own cluster, they own the cluster, they own the data. Now, if team B goes and say, oh, I want to read that data, and oh, by the way, but now I have to expand my capacity, or I have to give you access there. Who is going to, if team B is doing something bad, my engineers are on the hook. So it becomes a friction point between different teams. So it's really like an organization problem. But if you switch the model, now if you have a single cluster that is maintained by a single team, now no team owns the data that generates. So, and no application team is on the hook for something that other teams are doing. So it is much easier that, OK, I'm generating data. This is like the feed of events, say, new accounts created for users. Anyone that's interesting can just go in and get access and then consume the data and do stuff on top of it. So it is really like removing that friction point. And Pulsar was really born with multi-tenancy. It was really the first design goal there. So there is namespacing and tenants concept. There is enforcement of traffic and storage quotas, both at the single topic level or at more like a namespace or tenant level. There is really isolation for write and reads, which is really important at the low level to guarantee that someone reading will not impact performance on other people writing. And there's a lot of other tooling like dynamic topic isolation that can be used to move around things when tenants can cause impact on the cluster. And again, tying a bit back on the unified platform, we say, okay, Pulsar unified platform, messaging queuing. It is also, we can kind of like build a bit that more on the fact that, yes, we support multiple use cases, but it could be naive to think that we can live in a vacuum, that everything could be migrated to Pulsar in a whim, right? So there are other systems out there and use cases that are out there and using other technologies. And no matter what advantage we can say that Pulsar has, it becomes very difficult sometimes to migrate those use cases. People don't want to change their code for good reason. We have to retest it and use a different API, new models, and then making all that transition. But the reality is that these kind of like applications are going to be there. So if someone has written an application with a certain API, most likely that application will continue its life cycle with that API. And it is fine. The response that we have been giving in Pulsar community has been to, we can support multiple protocols. And actually, I think that Pulsar is kind of like the only platform out there for messaging that is truly multi-protocol. So we do have our own protocol. We do have our own set of features, which is where we can build new innovative features and making things very efficient. But at the same time, you can support out of the box different protocols like Kafka protocol or MQTT or MQP, and basically like making that transition, that migration story very easy for developers. And in a way, you can see that as a migration tool. At the same time, like if you say, okay, I have this application, I want to take advantage of some of the improvement that Pulsar can give in terms of multi-tenancy, in terms of operational improvements and so on. The answer is that you don't have to migrate your application. You can keep using your application. If it was written with Kafka Producer, fine, just keep using that. And it can work very well within Pulsar. And one thing that we have been working on, the team this year, has been KSN, which is Kafka for Streaming Cloud. Essentially, it is an improved version of KOP that was specifically designed for Streaming Cloud. And with the new 3.1 version, we have added support for Kafka and Pulsar compaction that work in the same way, and that was kind of like the last step. That right now we can support more complex Kafka application, for example, like K-streams or KSQLDB can work out of the box with KSN. And if you look at the performance, it is really on par with the native Pulsar protocol performance. So it's really great, and it is now GA in SN Cloud as of today. So, and I also suggest to check out the section from Dustin around using unlocking power of Pulsar for Kafka developers at 1:35 today. Going forward on the compute ecosystem, we have done a lot of work on improving the support for stream computing engines like Spark Streaming and Flink. Right now, we have collaborated with the respective communities, and the support has matured a lot. I also hope you can check the talking session from the data breaks on how we collaborated on the Pulsar Spark integration. And last but not least, suppose we also have Pulsar function, which we can announce that it is now GA in SN Cloud. And we have a lot of upcoming features for Pulsar function as well, from generic runtime to stateful functions and the auto-scaling for the function instances that's coming up. And last year, we announced that we were working on a streaming SQL support for Pulsar. Again, now this is on public preview. It is not a compute engine. It is not a fully fledged something that can do everything, but it is a very useful tool that can let you do like basic ETL, basic analytics on top of your data that you have already in your poster topic. And talking about autoscaling, we talked a lot in the past that Pulsar architecture makes it very easy for us to do autoscaling. Because of this separation between storage and brokers, it means that the brokers have no durable state, and we can basically transfer topic easily from one broker to another without needing to copy any data. That's very different from other systems. So we can scale up the broker, scale it down very easily, and we can do that multiple times a day based on traffic patterns. So the broker part on the autoscaling, it is now in private preview, but we are working as well on getting out the bookkeeper's scalability, both horizontally, adding more nodes, as well as vertically. Like if you're in a cloud environment, the size of the disk as well can be increased when there is more storage or more throughput capacity. And for more announcement and integrations here around Pulsar and Lakehouse. So Pulsar has been working with several of these communities around Lakehouse implementation, from Hoodie, Delta Lake, and Iceberg. And we can integrate very well with this Delta Lake, with these Lakehouse technologies in two different ways. So the first one is around sync connectors. So if you have your data in a topic, that data can be easily pushed to any Lakehouse system, and then you can run your own batch workloads from there. But one of the most interesting one is to basically integrate this Lakehouse technology at the tier storage level. So at this point, you can basically say that Pulsar can offload data directly into this Lakehouse format using different technology. And then you have two ways of reading this data out. The streaming way, in which basically goes through Pulsar API and the Pulsar broker. But you can also run a batch job, and that does the batch read directly from this tooling with their native APIs. I also want to call out that there's a session about streaming data into your Lakehouse from CG and Yingjun. So please check it out. And again, a few other features that kept us busy in the last year has been around how can we improve how we manage traffic in the Pulsar cluster. And so, as we say, Pulsar, his brokers have no durable state, so we can move traffic around. It is very easy. But what is typically tricky is how do we make that decision? How do you decide based on the load how to move topic, when to move topics from broker A to broker B? Because the traffic patterns are changing, and the perception that each broker has of others of the current load is also changing. And so we have basically rewritten the load manager, which is the component that decides the allocation of topics to brokers, to make it more scalable and to have a much fair and distribution, and to be much more quicker in a way that it reaches a stable state. So if you have any imbalance in the traffic across brokers, it will basically now react much more quicker and much more and reach the stable state in a much shorter time. And finally, one other thing that kind of is correlating to this is how can we minimize the amount of time that it takes to move topics from broker to another. Basically minimizing that small unavailability time during that transfer happens. So Hisung is going to do a session on describing the design and implementation of this new load manager at 3:35 today. Another aspect is around telemetry data. So telemetry data if you look at the amount of metrics that can be produced by a Pulsar cluster with many, many tenants, it can be big, and it can be overwhelming to any TSDB system. Especially like if you want to have very fine-grained visibility on all your topics and so on. So what the team has been working on is like, rehauling the whole way of how we measure things, how we collect the metrics, and how we expose them. So Asaf has done a presentation on the future of metrics and to illustrate the path that we have been following for solving this problem. And finally, I want to go back and have again call out one of the aspects of Pulsar and Streamlit Cloud. So one important part is that is a very flexible deployment model. So we can deploy Pulsar in Streamlit Cloud in many different ways. You can deploy as a hosted service in either GCP or AWS, and we can deploy also as a BYOC, depending on the different needs of that organization will have, but also as a private cloud, self-managed. And the final one is the edge. So we also are able to deploy Pulsar directly at the edge using these microclusters that can perform some computation at the edge directly and do like filtering, analytics, or even like using machine learning model as within the Pulsar function framework, and do all this anomaly detection and filtering at the edge, and then propagating back to cloud only the relevant alerts or relevant information. And so today we can announce that private cloud is now GA, and there is also a private cloud free trial that you can go and is completely free. So you can use all the same tooling that we use in SN Cloud in a self-managed way for free. So this concludes this session, and I hope you have a fun day today and lots of learnings with all the sessions and all the speakers. And I'll let you to the next one. Thank you.